millimeters in height, and then we have 57 millimeters in height, and 10 millimeters in height. Let's just divide these by the smallest, because if you divide this, that becomes 1. What is that equal to? What is this equal to? 19. Now that's obviously very suspicious. 19. I mean, how do you do 19 when there are only 15 hydrogens total in there? And then this would be about 3.3. So let's say 3-ish, about-ish, right? So I think this one we might have to fudge a little bit to fit the chemical formula. You guys with me? Mm-hmm. Okay. Let's look at multiplicity. What's the multiplicity of this? Now, this one is very broad, so there is obviously no multiplicity seen because it's broad. By the way, if it's broad, what is our suspicion? OH. Or? Now, there's no OH possible because there's no oxygen in there. So what's the other option?
Nitrogen.
NH, right? So,
NH.
maybe there is a hydrogen on, this could be the hydrogen on the nitrogen, absolutely. Okay, now what's the multiplicity of A? It's been blown up here. 2. So that's a double. Everybody agrees? So what's the multiplicity of these? Very quick, because I've been copying these every year. But it's been blown up here. 7. So please think about it. Because as I was saying the other day, there are some patterns that are a hint to us. If you have a doublet and a septet, what kind of a group is that an indication of? Louder, please.
Isopropyl.
Exactly. If you have a doublet and a septet, that combination is indicating that, oh, we probably have an isopropyl group, meaning this will be the septet and attached to 2 equivalent CH3s, those will be the doublet. Does that make sense?
Yeah.
Everybody? Okay, so now let's take a look at what we have so far. Do you all agree that so far we have seemingly an NH bond, right?
Yeah.
As we see that. We have an isopropyl group. How many carbons taken care of in these 2 pieces? 3. How many hydrogens taken care of in these 2
CH3,
pieces?
CH3H.
7
8.
total, are you sure? Oh, sorry, I forgot the CH3 there.
8.
8, right?
Yeah,
6 plus 7 plus. And how many nitrogens? 1. What's left? Our formula was C6, H15, and
we have 7.
More time, please.
3 carbons and 7 hydrogens.
And what is that?
That is
another isopropyl.
Exactly. If you had 2 of these, wouldn't that take care of it? Of course, we're not seeing any more signals because of the symmetry in the molecule. Both of the 2 isopropyl groups are absolutely identical. That's why you're only seeing 3 total signals. But does that make sense? Would that be reasonable?
Yes.
So what is the structure? So if you put it all together, what's the structure of this molecule?
Nitrogen bonded to the 2 isopropyls and the hydrogen.
Does that make sense, everyone? Are you guys okay? Questions? Okay. Is there another one that you guys wanted to go over together?
Not the same sheet, but like I believe the
Show it to me. I'll recognize it if I see it.
there's from here to like here. There's no it's not like this one is.
Oh, is that right?
Yeah.
Oh, shoot, I need to do that then. Will you send me an email as a reminder so I can do it?
Yeah.
Perfect, I'll do that. Any other spectra that you guys want to go over together, or should I pick?
I do have another one.
Which one? Show it to me.
So if you, this
Yeah.
one that we just did, if you just flip the page, and it's the second one. C4H9.
Oh, did we not do that? We did that. C4H9DR with 0 IHG. Did we not do that?
Wait, what?
780, 87,
I really need a better system of organizing these, right? I have them all over the place. Did you say C4H9BR, Carrie?
Yeah, it was the second one. The wrong one.
You know what, I can't find it. Can I just borrow yours? If that's okay. Oh, actually, I have extras. Where is my extras?
I think she was probably meaning the one with the
Perfect.
isomers of it.
Oh, I see.
Sorry, it was really messy.
No, you're good. I did have extras. Where did my extras go?
Well, we can just correct that one.
Oh, found it.
Okay.
Okay. Compound G. So, you know, we work on this guy together. It's on the flip side. It's compound G, also with the chemical formula C4H9BR. Am I right?
Mm-hmm.
Did everybody have that?
Yeah.
Cool. What's the IHD? If the chemical formula is also like the one above it, C4H9BR.
Wouldn't it be C4H10? You take out a.
Please go ahead, just tell me what's the IHD.
0.
0? Everybody agrees? No pi bond, no ring. Okay. How many signals total in this spectrum?
3 signals.
Actually, look closely.
Oh,
4.
there's a 4.
There are 4 signals. There is A. Can you tell me what's the multiplicity of A?
3.
1.
Should I zoom a little? Oops.
I think it's a triplet.
It's a triplet. Yeah, it's a triplet.
That's a triplet. What's the multiplicity of signal B? That's a doublet. Now the C is kind of hidden. It's that signal is C. It's a little bit hard to see, but if you look closely, do you see a 1, 2, 3, 4, 5, 6, maybe 7? Probably 7 because it looks like it is obviously 1, 2, 3, 4, 5.
So it's a
One of the two?
pentat.
It's either going, it looks like not a septet actually because I'm not seeing anything small here. So I'm talking about this signal.
So it's a pen.
Pentet, right? 1, 2, 3, 4, 5.
Yeah.
Okay, cool. And then there is another signal. This is a
1,
pentet.
2, 3, 4.
What is the multiplicity that you can see of signal D?
Sextat.
Do you all agree? 1, 2, 3, 4, 5, 6. Everybody okay?
Mm-hmm.
Okay, let's measure the integration. Do you guys have a ruler with you?
I have the same.
So do keep a ruler, guys, something small, something simple, because when you are going to analyze, let's say for the quiz or the exam, you need to have a good sense of what those are going to be. So, let's see. I'm going to call it 5 millimeters, 5, and this one ends here, starts, okay, so about 10 for that, 15 for this, and 15 for that. Yes, please.
Why are those bars so small in comparison to the signal?
What do you mean by that?
So like
Which
Yes.
bars?
the ones that we're measuring,
Oh,
it seems really small in comparison to the entire signal. Why do we?
that's the instrument.
Oh, that's just.
And in fact, the instrument has a place where as a user, we can expand this if you want to. Whoever did this didn't do it. Yeah. But do you all agree with the integrations, everyone?
Yeah,
So what
5
is
times
that
15.
ratio? Say that again? Oh, you're going right to left? Okay, that's fine, no, that's totally fine. So you're saying 3,
Yeah, I'll just go ahead and order the numbers.
totally fine, that's totally fine. Yep,
3,
A, B, C, D,
3,
right, absolutely.
2.
So what's the sum,
1.
guys? What's the sum of 3 and 2 and 1?
3 plus 3 is 6, plus 2
Is
is
that
8,
9?
plus 1 is 9.
So
Yep.
can we then therefore conclude that this is 3 hydrogens.
Yeah.
Yeah.
What's a group made up of 3 hydrogens?
A methyl?
Exactly. So there's a methyl there. There's another one with 3 hydrogens, the doublet. Would it be okay for say there's a different methyl there?
Yeah.
Yep.
And then what about the group made up of 2 hydrogens?
Methylene.
A methylene, there's a methylene there. And what about a group made up of 1 hydrogen?
Methylene.
Louder please?
Methine.
Methine, absolutely. Do we all agree?
Yes.
So let's take stock of what we have accounted for so far. Do we agree that there are 2 different methyls?
Yeah.
They're
Yeah.
not equivalent to each other.
Yeah.
And then there's a methylene and there's a methine, right?
Yeah.
Yep.
This one is a triplet. So what should it be connected to if this is a triplet?
It should be connected to the methylene.
Do you agree?
Yes.
Mm-hmm.
Okay, and this is a doublet. So who should this be connected to?
To the
Do you
The-
agree?
yeah.
The
This has to be
methine.
connected to that.
Yeah.
Methine is a sextet. So what does it have on either side? So let's just put this, let me just put this together. So do you agree that there is that, right?
Mm-hmm.
That's a doublet. And then we also have a CH2, CH3 because this is a triplet. Now methine is a sextet. So how many neighbors does it have?
It has 5.
So would it be okay for us to connect these two? 2 plus 3, has 5 neighbors. Everybody okay?
Mm-hmm.
What's the multiplicity of CH2? What's the multiplicity of methylene? Pentet. So how many neighbors? 4? 3 plus 1, 4 neighbors.
Yeah.
Agreed?
Yeah.
What else is left
The
though?
bromine, but we could stick it on top.
You're done? Sounds okay?
So which letter is which?
Okay, good. We should assign signals. In fact, that's a question I always ask. Assign the signals. Once you've come up with the structure, well, we have to be able to assign them to every signal. So which is A? Which methyl is A?
The methyl at the end.
Which end? They're both at the end.
CH2.
This one is A. Do you guys agree?
Mm-hmm.
And then, what about the methylene here? What is that?
C.
CC, good. What about the hydrogen on the methine right there? That's D. And what is this methyl?
B.
Okay.
Absolutely. So you're basically saying exactly which hydrogens correspond to which signals.
Mm-hmm.
That's okay, Carrie?
Yeah, I actually got it right.
Perfect. Why do you look surprised? It means you've been working at it. Great, good job. Any other spectrum that anybody wants to go over together? Okay, then I'll take same packet. I'm just randomly selecting this. How about C4H8O2, which is, it says number 3. Do you guys see it?
Yeah.
Okay, let's start with IHT. Please go ahead, tell me what is the IHT? I'm sorry, one more time, please.
1.
Okay, I heard 1. Someone confirm?
Yep.
Okay, cool. So either a pi bond or a ring. Everybody okay?
Yeah.
Yes? How many signals does this spectrum show?
3
So,
signals.
can I just call this A and B and C? Everybody okay?
Mm-hmm.
Let's do integration measurements. Where did I, my ruler? Gosh, keep forgetting. So, okay. So it looks like this is 15. This must be then about 20. This looks like it is also 20. So if those are the measurements, what do you think is the integration ratio?
1, 2, 2.
I'm sorry, could you say that again?
No.
443.
443? Are you sure? Again, remember integration, take it always with a little grain of salt. If you said 443, I see why you said 443 because you divided all of them by 5. But what is 4 plus 4 is 8 plus 3 is 11. We don't have 11 hydrogens. We have only 8 hydrogens. So that won't match. So always take it with a grain of salt. My suggestion is, this is my suggestion. When you're calculating the integration ratio, divide all of them by the smallest of them. And then see where that takes us. So if we have 15 and 20 and 20, and I divide all of them by 15, what do I get? Can somebody please tell me? 1 and what? 1.25? Did you get 1.25?
It's 3.
You got 1.5? 20 divided by 15 can't be
1.3.
1.3?
Yeah, I have it right here.
And 1.3 then?
Yes.
Oh, because 45, and then of course you got digits after that. Okay, cool. So now we have to, knowing that there are only 8 hydrogens in the molecule, we have to get a little creative, yeah. Suggestions, how could I adjust these integration ratios so they total 8?
2, 3, 3.
If I made this 2 hydrogens, and so again, remember it's 1.3. What if it's not actually supposed to be 1.3? What if it's actually supposed to be 1.5? Is that why you said 1.5? Okay. That makes kind of sense then. And then 3 and 3. What is 3 plus 3 plus 2?
8.
So then that would, so that, you guys see how we are fudging a little bit. Integration is a human process. So we have to be willing to fudge a little bit. So what we have decided is this is for 2 hydrogens, this is for 3 hydrogens, this is for 3 hydrogens. So do you think we can therefore call this signal a methyl group?
Yes.
B can also be a different methyl group. And A is a methylene group. Everybody okay?
Yeah.
Yes? Please look, let's look at the multiplicities. What's the splitting pattern of A? What's the multiplicity of A? It's a quartet. It's definitely a quartet. What about B?
Singlet.
What about C?
Triplet.
So please notice we have a quartet and a triplet integrating for 2 hydrogens and 3 hydrogens. What does that tell us? The combination of these 2 signals, what does that tell us? A quartet and a triplet integrating for 2 hydrogens and a 3 hydrogens. What must that be?
See, ethyl.
An ethyl group. There is an ethyl group in this molecule. Is everybody seeing that?
Yes.
And there is a different, totally different methyl also, which is a singlet, which is not coupled to anything. You good?
Yeah.
How many carbons is this? Total.
3.
How
3.
many hydrogens is this total?
2 plus 3, 8.
What's left?
A carbon and 2
A
oxygens.
carbon and 2 oxygens, and what else is left?
And IHD.
Your IHD is 1. We have not used that IHD yet. So can we take these 3 atoms, carbon, oxygen, oxygen, and put them together somehow with an IHD of 1? What would that be? Okay, what would the group be?
Carboxylic.
Not carboxyl, but I understand what you're saying though. You're saying this group,
Oh, see.
right? That's taken care of the carbon, taken care of the 2 oxygens, and taken care of the IHD. Everybody with me?
Yes.
So what's left? Nothing. Everything is now accounted for. All we have to do is put these 2 pieces together. Exactly. So what, please go ahead first, go ahead, put these 2 pieces together and tell me what structure do you come up with? How many ways can you put these 3, sorry, not 2. How many ways can you put these 3 pieces together? 2. What are those 2?
H3C bonded to a carbon, double bonded to an oxygen. Uh-huh.
Agreed? Two esters, two different esters, exact same everything. So how do we decide which of those two esters is this spectrum? So here's where we need to be able to say, okay, can you tell me what will be different between the NMR spectra of these two compounds? Louder?
Multiplicity.
No, actually not.
Where they are.
This is supposed to be a trip. Exactly. This is quartet. This is singlet. This is triplet. This is quartet. This is singlet. No, the number of signals is exactly